Okay, let's continue. We'll study the area of a disk. So, consider a disk of radius r. So, this is a disk of radius r. So, we can ask how much area does this occupy? What is the area of the disk? So, first we can consider the unit disk. Consider the unit disk. So, this disk has radius 1. This is the unit disk. Now, we will approximate this disk using small boxes, using a grid of boxes. We will grid of small boxes. Okay, so fix a small delta greater than 0. This is an informal proof, by the way. This is an informal argument. Okay, so we will approximate the disk. Consider the unit disk. Consider the disk with radius 1. We will approximate the disk using a grid of boxes. So fix a small delta greater than 0. Now approximate the disk. By the grid of boxes as shown. So here is the unit disk. Here is the center and this is the radius. So what you can do is consider a grid of boxes. Okay, now so in this grid, so each box has side length delta. Okay, so consider this grid of boxes. Each box has side length delta and the original disk has radius 1. So you are approximating the unit disk using small boxes of side length delta as shown. So now note that area of the disk is roughly number of boxes hitting the disk times the area of each box, which is delta square. So approximately it is the number of boxes which are hitting the disk times the area of each box, which is delta square. That is roughly the area of the unit disk. For smaller and smaller delta, this approximation becomes more and more accurate. Okay. Now consider a dilation or scaling of this figure by R. We have, now if you scale the above figure by R, this is what we get. We have the original unit disk, right? And we have approximated the unit disk using small boxes of length size delta, side length delta. So this is the unit disk, and what we can do is we can scale this entire figure, the disk and the approximating boxes. We can scale this figure by R. That means we are just multiplying the lengths by R, all the lengths by R. Then what we get is, so typically you get a disk of radius R. You're scaling the disk of unit disk by R, you'll get a disk of radius R. And each of the approximating boxes, it will become, the side length will become R delta. And you have various boxes hitting the disk again. So note that if you have n boxes hitting the disk, then in the scaled picture also you'll have n boxes hitting the disk. So scaling, this is because scaling preserves form and changes size. So you are just changing the size of things, you are not changing the structure or the form of things. So structurally the picture will still be the same. You'll have a disk and you have some approximation by boxes. It is just that the size of the disk will change, the size of the approximating boxes will change, but still if there are n boxes hitting the disk in the original picture, you will still have n boxes hitting the disk in the scaled picture. Okay, so we have considered a dilation. First we have considered a unit disk. We have approximated the unit disk by small boxes of side length delta, and now we have scaled that picture and we got this new picture. Okay, now in this picture, hence, so area of radius 1 disk. So area of radius 1 disk is approximately n delta square, right? So you have n boxes hitting the disk and each box has size delta square. So this is roughly n delta square. Area of the radius 1 disk is n delta square, roughly n delta square. Area of the scaled disk, a radius r disk, is roughly, you'll still have n, but you get r delta square. So this is n r square delta square. Hence what we observe is area of radius r disk is r square times area of radius 1 disk. This is the main observation. If we scale the unit disk by r, you are scaling the areas by r square. Area of radius r disk is r square times area of radius 1 disk. Okay, now we define, so this area of radius 1 disk is a constant, right? This constant we define as pi. So this is a constant. This constant we define it to be pi. Numerically, it turns out pi is roughly, or pi is 3.1415 and so on. Okay, so pi has this decimal approximation. So area of the radius 1 disk is, we define area of the radius 1 disk to be pi, and numerically it turns out to be close to 3.1415. So once we have considered the area of radius 1 disk as this constant pi, we have area of radius r disk this is pi r square. So r square times the area of radius 1 disk, which is pi. Area of a disk of radius r is pi r square. Right, so that's all for this part. See you in the next part.